will help you to overview and lesson today about miscellaneous exercise on graphical representation of real function. First example, we have here graph the function f where f of x equal x squared and x, where x power 2 where x less than 0 and x where x more than or equal 0. We have here f of x equal x power 2. You have the vertex 0 and 0. From here 0 and 0, and move 1 to the right and up to 1, and 1 from the left and up to 1, and draw the curve of second degree. Here is the curve of second degree. We have condition here x less than 0, so we will draw the left and clear the right. And here we have x when x more than or equal 0. I will take 2 points to x, 2 values to x, 0 and 1, and try to draw. By substitution about x equal 0, it will be 0, and x equal 1, it will be 1. So you have 0 and 0, and 1 and 1. Here this is x power 1, so it will be straight line. It will be drawn as a straight line. Here, like this. So you have a curve and a line, and the value of the function f of x equal x power 2 and x. The domain of the function is R, and the range is from 0 to positive infinity. And the monotony of the function is decrease from negative infinity to 0 and increase from 0 to infinity. And the f is increase from 0 to infinity. We have here the following. Write the rule of the function f represented graphically by each of the following graph. The first one, the vertex is negative 2 and negative 3. So the function f of x equal x plus 2 power 2 minus 3. And here we have the vertex 2 and negative 3. So the function f of x equal absolute x minus 2 minus 3. And here the rule is third degree, so f of x equal the point of symmetry is negative 1 and negative 3, so the rule of the function is x plus 1 power 3 minus 3. Another one, to draw the following function. So we have here g of x equal 4 minus x power 2. So the vertex is 0 and 4, and the function will draw from 0, move one step to the right and down to 1, and one step to the left and down to 1. So the curve of the function will be like this to intersect the x-axis at negative 2 and 2. This is the curve of x, the curve of the x power 2 minus negative x power 2 minus 4. Now we will try to draw h of x equal absolute 4 minus x power 2. First, I will redefine the absolute value function. The absolute value function, absolute 4 minus x power 2, it will be 4 minus x power 2 and negative 4 plus x power 2. 4 minus x power 2 when x belong to closed interval negative 2 and 2. Why? So 4 minus x power 2 where x belong to closed interval negative 2 and 2, because the function is positive from negative 2 and 2 from this graph, and the function is negative from negative infinity to negative 2 and from 2 to infinity. So x belong to R except closed negative 2 and 2. To draw this function, I will find the vertex here 0 and 4 and draw the function from negative 2 and 2. This is the rule of the function. Because x from negative 2 and 2. The second one, negative 4 plus x squared, it will be the vertex of the function, it will be 0 and negative 4, and the curve is upward. 0 and negative 4 will be here, and the curve will move 1 to the right and up 1, and 1 to the left and up 1. The curve will be like this. And here we will take x belong to R except negative 2 and 2, so I will cancel or clear the line before 2 and after negative 2, so the curve will be like this. So the function will be from negative 2 to 2 like this curve. The domain of the function is R and the range 0 and infinity. The function decrease from negative infinity to negative 2 and increase from negative 2 to 0 and decrease from 0 to 2 and increase from 2 to infinity. We can use GeoGebra to draw this function like this. I will use GeoGebra. The function is y equal y equal absolute 4 minus x power 2. So y equal absolute 4 minus x power 2. So the function will be like this. Another one, if the function f where f of x equal 1 over x, graph the function L in the following cases. The first one, L of x equal absolute f of x. So it will be absolute 1 over x. I will redefine the absolute. So it will be 1 over x where x more than 0 and negative 1 over x where x less than 0. 1 over x will draw in the first and the second the point of symmetry. The point of symmetry will be 0 and 0, and the curve will draw in the first and the third quadrant. So the function will be in the first quad and in the third quad. The condition here x more than or equal 0, so I will clear the left branch, and here we have negative 1 over x where x is less than or equal 0. I will draw in the second and the fourth quadrant, so the function will be like this. And we have here the condition x less than 0, so we will take the left part and clear the right part. The domain of the function is R except 0, and the range is from 0 open to infinity. The function is even and not one-to-one, and increasing from negative infinity to 0 open and from 0 to infinity. Here we have 2 plus absolute f of x. 2 translates the function 1 over absolute x 2 units on positive direction of y-axis. So from 2 on y-axis, I will draw a new asymptote and draw the same function the same function of absolute 1 over x from the first and from the second. And here we have absolute f of x minus 2. So it's the same curve of 1 over x, absolute 1 over x by translation 2 units on positive direction of x-axis. So from 2 in positive direction of x-axis, I will draw a new asymptote, and I will try to draw the two curves from the first and the second. From the first and from the second from the new asymptote. Thank you very much, and see you later.